Hi, so this is a project that I did with 3 other students, Beck, Justin, and Shay, as a final year project for electrical engineering. So basically, it's a digital oscilloscope with 2 input channels and 1 output for a function generator. The function generator can go up to 25 kHz, and you can select the various waveforms here, control the amplitude, DC offset, go for random noise, whatever you want. And then on the input channels, we had one mode where it was low pass, so we had to take in a signal from 0 to 250 kHz, and then there was a bandpass mode from 650 to 750 kHz. And so this was a big project. We all had parts to do, and so my part was the LCD touchscreen interface and the analog front end on the PCB below that did all the signal handling and then presented the signal appropriately conditioned to the ADCs to then be processed and then sent over Ethernet to the PC software to be displayed. And so this red board below is the TVC connected launchpad, which is pretty cool to use. It's a great board. And so I'd never done any screen stuff before, but I didn't use any libraries for this. I just basically designed the images myself, then wrote a script to convert them to an appropriate format to be displayed on the screen, and then they just get loaded up. And so yeah, you can just control it all on here. And so say it's got all the functions you would expect of your oscilloscope, so you can turn channel A, B off, you can change the time per division, you can change the volts per division for each channel, you can AC DC couple them, and so then with the trigger settings, you can select the trigger, you can arm the trigger, you can force the trigger, you can move the trigger around, and yeah, there's just heaps to do. This was a big project. We learnt a lot, did a lot, and yeah, and so now I'll just take off the screen and just show you the PCB underneath. And so here we've got the analog front end for channel A and the power supply circuitry over here, and then there's some voltage protection stuff up in here. And so then if we try to look underneath, also we got the TIVA board under here, and then we've got the analog front end for channel B underneath there, and then some function generator stuff and some more voltage protection underneath there. So overall it was a difficult project, but I mean, we all learnt a lot and made a pretty cool product at the end.